Hey guys, today I'm going to be talking to you about the engineering design process. This is competency number 2 in Unit 2 for project design and user experience. I'm just going to go over basically these three right here: identify the steps of engineering design process, apply the steps of the engineering design process to a specific project, which I did, and I'll show you. Um, and explain how each step of the engineering design process relates to a specific project. These are things that you should be able to do. And I just went through this process and kind of showed you how to really use it. So the first thing we're going to look at is the engineering design process itself. This is the actual model that NASA uses for their engineering team. So they start off with ask, and that is to identify the needs and constraints, which is basically asking a question, finding out a solution to the question, and then going to the next step, which is researching the problem. So you're going to basically go online to videos or different pictures and stuff like that and look up ways to uh, solve your problem by using other people's ideas before you and then making those better by making your own. And then imagine is going to be our brainstorming where we come up with different solutions, and then choosing one of those solutions leads us to the planning phase, which is basically just planning out what design we're actually going to start making. And once we have that design, we're going to go over to making our prototype. Once you make your prototype using your plan, you're going to go in and test what you originally asked yourself about. So, like me, I built a little bridge. So, my test was how strong was the bridge going to be? And I tested that. And then, once you test it and evaluate based on your information and data that you record, you will go to the improve step, which is a redesign as needed. And this process is basically a continuous loop in a circle. There's a lot of different models for this. So you can actually go to Google and put in engineering design process, and you will see all these different models. And most of them are almost exactly the same with a few steps added or removed. Some of them can be combined. This one right here has a few of them combined, but it shows 7. But we're basically going to be looking at this one right here and then using that in our little video here. Hey guys, just reviewing my video, and I just wanted to point out that this engineering design process model is very much the same as the NASA one that NASA uses and the one that we usually consider, but this one also has like what to use in it. So I wanted to point it out and use it as well. I didn't include it in the packet because I didn't want to confuse people, but this one right here, if you look at it, it just has like the two things that you can look at: what is the problem, how can I solve it, and it kind of gives you the rundown of each of the steps as you go through the engineering design process. So using this one right here, you can actually get an idea of what each um, piece of the process should look like, and you can kind of see what, like in the build and create, follow the plan and diagrams, build your model, and create the solution. So, and another thing that I didn't mention in the original video was that you don't have to follow it in a complete circle. You can actually go from 1 to 2 back to 1 if you feel like you're not answering the question and your brainstorm's not working too well. You can loop between these, like let's say 1 to 3. Okay, if I get to 3 and I'm like, maybe I just need to re-ask the question, and I move back to 1. Okay, and you don't have to like maneuver through this whole circle before you can change back to a previous step. And that being said, you don't always have to go back to number 1 either. You can go through the brainstorming, get to your plan to design, and then start to build and create, and you realize, oh, my plan and design's flawed. I need to change the way my model looks. So now you're going to go back to the brainstorming, look at your other sketches, and then come up with a new plan. And so you can refer back to these steps. It's a very fluid system. It isn't very, you don't have to like stay in this little circle here. Okay, so keep that in mind while you're building. And I just wanted to add this in to kind of give you a little help if you're building a project and you're like, oh, I got to follow this in order. No, you don't really necessarily have to follow it in order every time. Okay, so like I said, when I originally started, I got to the build and create, and I was like, wow, it's really hard to build this without some extra hands. So I had to like rethink how I was going to build it. So my plan and design kind of changed. So I went back and forth between building, create, and plan to design for a little bit, and then I kept going. So keep that in mind as you're going through. Okay. So I have actually prepared you a engineering design process worksheet that you can go home and do your own little project. I ended up doing the bridge, and you can do that one as well if you like to. And I'm just going to go through what I did, and I'll show you on my little packet that I have here how I went and did that. So looking at the engineering design process, here's our little model. It's on your page for you. The first one was what is the problem and how do I solve it? So my first little one right here, I put on I need a bridge to connect to one thing to another, and then how am I going to solve that problem? I'm just going to use giant popsicle sticks and little popsicle sticks in order to complete that. So that's what I started doing, and then my research. So moving down, which says look up some details about your problem and solution. I went online and I looked up on YouTube a video, how to build a bridge by Mr. Engineering Guy, myfarmlife.com, a home garden, 12 steps for building a bridge. And number three, the third one I used, I put 5 on your sheet, but you don't have to use all 5. Extremehowto.com, building a bridge. So those are 3 pages or one video and 2 pages that I looked at to get my ideas from. Once I got my ideas, I went to the Imagine, which is the brainstorming, and I wrote down or drew some little designs. So you can see my little designs here. The first one, design number 1, has the top view and the side view. I have a design number 2, which the top view was kind of the same for all of these. I was just making a floor out of the small popsicle sticks. So this is my second design that I came up with right here. And then my third design, which was this one right here, I came up with just to kind of make like a structure that was a little bit different from the other 2. And I saw a couple bridges online that looked like this. So I ended up going with design number 1 because it used the least amount of popsicle sticks. And I felt like of a lot of the bridges I looked up had this particular design, so I figured it must be a really good design for strength. So I ended up going with that first design, and then I came up with my plan. So I had basically a little tacky glue, which is kind of like white glue. It's what we had here at my house. I'm using large popsicle sticks for the sides, and then I have these little tiny popsicle sticks for the floor. And I came up with a plan. This is my drawn out plan. I put each side has 2 large popsicle sticks for the bottom, 1 large for the top, and then 4 for these little webs that go in between the little V shapes. So those are my each side, and then I took both sides and I made them. So my plan down here says build each side to match each other. So I basically laid them on top of each other, or laid the second one on top of the first one after I got done building it to make sure they matched, and then attach each side to one another using the short popsicle sticks, and then test when finished. Now, if you'll notice up here in your plan, it doesn't really say anything about you having to rethink your plan at that point. The create step says now you're starting using your plan. Let's go down to that in the video here. So here's our plan, and then create. Now you're starting to use your plan and design and build your prototype. This is a hands-on experience, and as you build, you may find out that you will change up your plan. This is very true because even while building mine, I had a lot of issues with it being stable side to side, and I had to adjust the way I was building because I was building by myself and I didn't have anybody else to hold each side as I was building. So it became a real issue for me in order to get that built properly where it would stand up on its own and be kind of sturdy. So once I got it built, I did the testing. I put in my little sheet here, one of my testing on my prototype. So mine says strength, and there my data table. I have the item that I used. I had a little dumbbell that I have it here that my wife uses to work out with, and it was 5 pounds. So I put that on top of it. It held it just fine. We also have brick pavers outside that weigh about 10 pounds. So I put that on there after the dumbbell, and it held that just fine. Then I put the combination of the paver and the dumbbell in there for 15 pounds, which it also held. But then when my last one was 2 pavers, which was 20 pounds, my bridge started to crack a little bit, and it didn't feel very stable, and it kind of broke sideways. It didn't break vertically like up and down, but you'll see in a minute. I'll show it to you. It kind of flattened out. So I put in no, it was not stable at that 20-pound mark, and my testing was done with the results. The bridge can hold up to 20 pounds. Any more wouldn't be recommended because we heard a crack with the 20-pound weight. The last step in the engineering design process will be improvement. So obviously, here's my design. Let me show you that. Here's my design. It flattened out. I don't know if you can see it, but it's kind of flat. It flattened after I tested it, and you can see my little sticks falling off there. I can try to straighten it back out. There you go. You can see it was flat like this, where you have the little bridge, and I have that piece hanging down now. One of the things that I would improve on, building prototype wise, this tacky glue takes a minute to kind of dry. So instead of using tacky glue, I would actually use my hot glue gun next, because it dries a lot faster, and honestly, it probably is more sturdy anyway. I just couldn't find that when I was building, and I found it afterward in the garage when I was looking in there. So I would probably use hot glue to build my next one, and then I would find a way to strengthen the sideways alignment. Like you can see, I tried to do it with the sticks on the top, and there was 2 sticks in the middle that's fell now because it kind of broke off. But these 2 sticks in the middle, right, kind of went. I don't know if I can do this anymore. It's kind of falling apart really bad. Anyway, I had 2 sticks in the middle to try to eliminate some of that sideways lean. But I'm gonna have to find a way to improve it to not shift like this, and that would probably allow it to hold a lot more strength other than the 20 pounds that I tested. And we will move on to making our new plan. So when I go back, my new question after I built this to ask for the next part is, how can I stabilize this sideways portion? Well, now I'm going to try to come up with a way to stabilize that. So I'll go in to my web page, and I would go to building, or let's just do bridge designs. And I would probably just look at pictures for me. Like this one here looks kind of similar to mine. These are all sideways pictures. So if we look at actual pictures of these, they have a lot of things looking like cross beams across there. And in this picture, you can really see it. There's a little X in between each one of these. So I might put like a little X kind of like that, and maybe with 2 little popsicle sticks between them. And so I'd try to make this kind of structure in between my 2 sides to try to support it a little better. So it has this point in the middle and these 2 points at the top, these 2 points at the bottom, all holding together. And then that would kind of stabilize the back and forth movement between each side. And then, so that's my research part and this little reiteration portion. And then imagining the new possibilities, I kind of just showed you my brainstorm where I had these 2 together. I don't know really that that'll work, but my plan would be just to glue these 2 together like this in an X, make sure each side is flat with each other. And then I would glue each side to my sides on the bridge and try to stabilize it left to right. After I did that, I would go in, that would be the plan and create. So I'd build it with the create portion, and then I'd retest it. And so you keep doing this loop over and over again to do the engineering design process so that you can make things the best that they can possibly be. Because you may have an item that you really like that works, but everything can be improved. And most of the time, you're looking for ways to make things the most efficient to build. Like when I first started, I said these use the least amount of popsicle sticks on the side. I didn't want to use a whole bunch of these big popsicle sticks, but I figured it would still be just as sturdy as if I built the one with more popsicle sticks. So that's being more efficient with your build, more economical, and that means you spend less money. Okay, and then more environmentally safe, which I don't produce as much waste if I have to cut things off and stuff like that. And then in terms of real world applications, you want things to look really good too. Like this thing does not look pretty, so I would have to like get some paint and paint it up, make it look nice. So all of that stuff would actually go into the engineering design process. After I got my simple prototype done, then I can start worrying about those new problems and keep using my engineering design process in a loop. And I will just keep doing the same thing over and over. That way, the end product will be something really nice and that looks good, doesn't cost a lot of money to make for the strength that it offers, and you have something that you are proud of building and using the engineering design process to give you something that you enjoy. So I hope this video was very useful, and I look forward to seeing any of your projects that get submitted. If you would like to submit it, please just email me. My email is jdoris@pcsd.ms. I would love to see some of your projects and just hear from you in general with all that's been going on. So if you have any questions, please feel free to contact me, and I will look forward to hearing from you in the future. See you later.